Greenland is the largest island in the world and one of the most inhospitable places on the planet. Almost 82% of its surface is covered by an ice sheet that in some places reaches 3 kilometers in thickness, a glacial mantle that accumulates 8% of all the fresh water on Earth and which, if it melted completely, would raise sea levels around the world by between 6 and 7 meters. For centuries, what lay beneath that ice was completely unknown. Then came the penetrating radars and the satellites, and what they revealed beneath that white, endless sheet left the scientific community speechless. A hidden landscape of mountains, canyons, lakes, and geological structures of a scale and complexity that no one had imagined, including what could be the largest scar an asteroid has ever left on the surface of our planet. Leave your like, subscribe, and share. Let's begin. The instrument that made it possible to see beneath the ice of Greenland is the ice-penetrating radar, known in English as ice-penetrating radar or radio echo sounding. The principle is conceptually simple. Pulses of radio waves are emitted from an aircraft flying over the ice. Those waves penetrate through the glacial layer, bounce off the rocky surface below, and return to the sensor. The time they take to return allows the calculation of the ice thickness and the topography of the bedrock with great precision. The technology has existed since the 1960s, but modern systems, such as the CRESIS radar developed by the Center for Remote Sensing of Ice Sheets and Snow at the University of Kansas, have incomparably greater resolution and penetration capacity than the original equipment. Using these radars, combined with data from gravimetry satellites such as those of NASA's GRACE mission, researchers have built over the last 20 years the most detailed map ever produced of the bedrock beneath the Greenland ice sheet. The Bed Machine Greenland project, led by Mathieu Morligam of the University of California, Irvine, and published in the journal Nature Geoscience in 2017, integrated data from more than 150,000 kilometers of radar profiles to produce a map of the Greenland bedrock with a resolution of 150 meters, the most precise until then. And what that map showed was a territory completely different from what previous models had estimated. Beneath the ice of Greenland, there is a system of canyons of colossal dimensions. The largest, identified in 2013 by researchers from University College London, using data from NASA's Aerial Radar Operation Icebridge, has a length of at least 750 kilometers, making it the longest known subglacial canyon on Earth, comparable in length to the Grand Canyon of the Colorado, although with different morphological characteristics. The depth of the canyon varies between 200 and 800 meters, and its width reaches 10 kilometers in some stretches. The researchers, whose study was published in the journal Science, determined that the canyon was carved by a river that flowed beneath the ice or before the ice covered the area, possibly several million years ago during a period when Greenland was fully or partially free of ice. But the finding that has most captured public and scientific attention in relation to the Greenland subsoil is the discovery of what is believed could be the largest asteroid impact crater ever found beneath an ice sheet, and one of the largest in the world in terms of diameter. The crater, located beneath the Hiawatha Glacier in northwestern Greenland, was identified in 2018 by an international team of researchers led by Kurt Kjær of the Natural History Museum of Denmark, using radar data from the Operation Icebridge mission combined with images from the Landsat Earth observation satellite. The study was published in the journal Science Advances. The Hiawatha crater has a diameter of approximately 31 kilometers and is buried beneath nearly 1 kilometer of ice. Its circular shape, with a central peak characteristic of large-scale impact craters, is clearly visible in the radar maps. Analyses of sediments collected from the river draining the Hiawatha Glacier found shocked quartz, a type of crystalline deformation that only occurs under the extreme pressures of a meteoritic impact, as well as impact glass particles and grains of minerals with textures that are diagnostic of impact. Those findings confirm that the structure is indeed an impact crater and not a geological formation of some other origin. The question of when the Hiawatha crater formed is one of the most active scientific debates in current planetary geology. The first estimates, based on the structure of the ice layers above the crater, suggested that the impact could have occurred between 12,000 and 3 million years ago, an enormous range that researchers have attempted to narrow with additional analyses. A study published in 2022 in the journal Science Advances by researchers from the Lamont Doherty Earth Observatory of Columbia University, using fission track dating and apatite minerals extracted from sediments of the river draining the glacier, obtained an age of approximately 58 million years for the impact event, which would place the crater in the Paleocene, much older than some earlier hypotheses had suggested. However, the debate is not closed. Other researchers analyzing the same set of geochemical data argue that the age of 58 million years reflects the thermal history of the rocks before the impact and not the date of the impact itself. The scientific controversy over the age of the Hiawatha crater perfectly illustrates the challenges of studying geological structures buried under kilometers of ice. Direct access to the rocks of the crater is extraordinarily difficult, and the available data is obtained mainly indirectly, through radar, satellites, and analyses of fluvial sediments. Leave your like, subscribe, and share. In addition to the Hiawatha crater, the ice-penetrating radars have revealed beneath the Greenland ice sheet a system of subglacial lakes far more extensive than previously thought. The existence of lakes beneath the Antarctic ice had been known for decades, with Lake Vostok, at 250 kilometers in length and 50 kilometers in width, being the most famous. But in Greenland, the scientific community took longer to document equivalence, partly because the Greenlandic ice is more dynamic and warmer at its base than the Antarctic ice. A study published in 2022 in Nature Communications by researchers from the University of Alberta identified 54 subglacial lakes beneath the ice of Greenland, including several that store volumes of water of cubic kilometers and that drain periodically in episodes that accelerate the movement of the glacier above them. Those drainage episodes, in which a subglacial lake can empty within days or weeks, have direct consequences on ice dynamics and therefore on projections of glacial mass loss and sea level rise. When the water of a subglacial lake drains to the base of the glacier, it acts as a lubricant between the ice and the rock, accelerating the flow of the glacier toward the sea. Climate models that do not incorporate the dynamics of subglacial lakes tend to underestimate the speed of ice loss from Greenland, which has direct implications for the projections of the Intergovernmental Panel on Climate Change, the IPCC. NASA's Operation Icebridge mission, which operated between 2009 and 2020, was the longest and most comprehensive aerial observation project ever carried out over the terrestrial poles. For 11 years, aircraft equipped with ice-penetrating radars, altimetric lasers, gravimeters, and high-resolution cameras flew over the Arctic and Antarctica, accumulating data that have generated hundreds of scientific publications. The mission was designed to fill the temporal gap between the ICESat satellite mission, which ended in 2009, and its successor, ICESat-2, launched in 2018. The Operation Icebridge data continues to be analyzed and produces new discoveries years after the mission ended. In 2021, the European Space Agency's Cryosat-2 satellite, which measures the height of ice surfaces with centimeter precision using an altimetric radar, detected in the northern region of Greenland a series of depressions in the ice surface that researchers from the Centre for Polar Observation and Modelling at University College London interpreted as the surface footprint of active subglacial drainages. The depressions, between 10 and 70 meters deep and several kilometers in diameter, formed within months, indicating that the subglacial processes beneath the Greenland ice are far more dynamic and rapid than previous models had suggested. Beneath the ice of Greenland, there are also volcanoes. In 2016, researchers from the Helmholtz Center for Geoscience Research in Potsdam published a study in which they identified, using radar and reflection seismics data, what they interpreted as an active volcanic field beneath northeastern Greenland, with at least one structure that could be a volcano with activity within the last 10,000 years. If volcanic activity beneath the ice is confirmed, it would have implications for understanding glacial dynamics in that region, since the geothermal heat of the volcanoes can melt the ice from below, creating basal meltwater that accelerates the glacier's flow. Everything that lies beneath the ice of Greenland, from 700-kilometer canyons to asteroid craters, subglacial lakes, and possible volcanoes, forms a geological system of a complexity we are barely beginning to understand, and the urgency of that understanding is not purely academic. The Greenland ice sheet is losing mass at a rate that has accelerated consistently since the 1990s. Measurements from the GRACE satellite and its successor GRACE-FO indicate that Greenland loses on average between 280 and 300 gigatons of ice per year in the last decade, contributing approximately 0.7 millimeters to the annual rise in global sea level. What happens to that ice in the coming centuries will depend in part on the topography, geology, and dynamics of a territory that still, in many essential respects, remains hidden beneath kilometers of ice and secrets that the radars have barely begun to reveal. Leave your like, subscribe, and share. Until next time.